Welcome to my tutorial on seamlessly transitioning between images during a rotation of only 90 degrees. These images are rotated on other than layer center, and in this case, they're rotated on a corner. This is the effect that we'll create. Each image occupies the same screen location and rotate together around a shared corner which moves horizontally across the screen. As the initial image fades away, the next is revealed. The rotation occurs around any shared rotation point. As an exercise, I'm leaving it to you to create this effect using another corner or any other side as the shared rotation point. In this tutorial, however, I will only demonstrate how to create the effect displayed. Creating this effect is actually quite simple once you know how. This tutorial will provide you with the information that you need toward that end. This effect works best if the two images share the same characteristics such as aspect, size, scale, and rotation point. Fail to do that, and any number of complications will arise. Now, I'm going to go over how to create this effect. You may need to crop these images to give them both the same aspect. I use the cropping tool in my tools for ProShow. For this tutorial, I'm cropping my images to the same aspect as that of the frame. My source images have an aspect of 4672 by 3104, and they're cropped to an aspect of 4672 by 2628, which is also a 16:9 aspect. Next, this information is entered into the layer information section's first user-defined value. Next, I set each of the findings layers to use the layer aspect just entered. They use the layer's zoom value of 65 when unrotated. Upon entering the zoom value, I'm immediately provided the layer's width and height for both the rotated and unrotated states. However, before I review the setup for the initial and next image layers, I need to discuss the approach used to obtain the setup values. This will help you understand how the effect is actually created. I'll return to this section and finish the explanation later on in this tutorial. The initial image and frame have the same aspect, which is 16:9. That means a one-to-one relationship exists between the horizontal and vertical axes of the frame and each layer. Therefore, the zoom values of each layer's axes represent its width and height respectively. This initial image is rotated minus 90 degrees on its lower left corner as shown here. After completing the rotation, the layer's pan is still showing as 00, which is screen center. And clearly, that's not correct. The location of the center of a layer is the layer's true position. In these graphics, the diamond shape represents the layer's centers. The on-screen location of that diamond shape is the layer's true position. This screen shows the layer's location both unrotated and rotated within the ProShow slideshow frame, and this is the location of that slideshow's frame. This represents the unrotated layer itself, and this is the rotated layer. Now we need to find the rotated layer's true position because the layer was not rotated on layer center. Its current pan values are incorrect with respect to its true position. Once the layer's true position is known, that information is used to reposition the layer as desired. In this case, that's screen center. Now once there, the rotated layer's zoom values are adjusted to match the unrotated layer's width and height. So the displayed values or relationships are used to obtain the unrotated and rotated layers' widths and heights, and their values are then combined to become pan values that are used to place the rotated layer back to screen center. In this view, the unrotated layer's position is given by p sub L, and the rotated layer's position is given by p sub L prime. The equations given here define how to arrive at L prime's position. The results of those equations are then used to reposition L prime to the position of L, and this is a demonstration of how that repositioning works. In reality, the layer repositioning and any changes in zoom occur simultaneously. The process of obtaining the next layer's starting position is similar to finding the initial layer's true position when it has been rotated minus 90 degrees. The next image's starting zoom values are the initial layer's final zoom values. The next image's pan values are the same as the initial layer's pan values when rotated at minus 90 degrees, with the exception that the pan x value is a negative value instead of positive. This adjustment places the layer's true position at screen center when rotated 90 degrees on its lower right corner. With setup complete, the images rotate and change their zoom values simultaneously, revealing the next image as the initial one fades away. We now apply this information to the actual images themselves. Note that while transitioning between images, the initial image rotates 90 degrees counterclockwise while the next image rotates 90 degrees clockwise. Because each image layer maintains the same size during the rotation, the result is a smooth and seamless change between images. This is the effect once again displayed. Okay, now we're going to go back to review the Tools ProShow settings displayed earlier. To recap, the images and frame here have the same aspect, 16:9. The images have a zoom of 65 for each axis that sets their width and height at rotation values of 0 degrees of rotation and at 90 degrees of rotation. The initial and next images use layer 1's 90-degree rotation width and height values as their zoom values. Note that the rotated 90-degree width and height is the same as the initial layer's base zoom value of 65. Providing rotate center values for the initial and next images lets the location of layer section provide actual location information. This section is used to identify the layer location based on a rotation amount, the rotation center value from the settings section, and the desired actual position. When provided a user-defined rotation value and a specific desired layer location, Tools for ProShow supplies the associated pan values for that layer location. Note that as the layer rotates from 0 to minus 90 degrees, the zoom values change from a starting zoom of 65 for each axis to ending zooms of 36.56 for the x-axis and 115.56 for the y-axis. With the initial image rotated to minus 90 degrees, it is repositioned to screen center using pan values of 50.78 for the x-axis and minus 25.28 for the y-axis. Note, the next image rotates from 90 to 0 degrees while changing its starting zoom from 36.56 for the x-axis and 115.56 for the y-axis to an ending zoom of 65 for both axes. For the next image to appear at screen center while rotated at 90 degrees, it requires pan values of minus 50.78 for the x-axis and minus 25.28 for the y-axis. After setup's complete, the result, which is demonstrated here several times before, is going to be demonstrated again, are for images cropped to the 16:9 or 16:9 aspect. We're going to follow that with a demonstration of the same effect using two 3:2 aspect images within a frame. The ProShow functions of pan, zoom, and rotate center are all interrelated, and their relationships are given here. A ProShow layer's width and height are related to the layer scale, aspect, and zoom setting. These relationships are things that I discovered in June of 2011, and it made me the first ProShow user able to use the rotate center function far beyond what direct functionality ProShow provides. The relationships given here can help you obtain information about your layers that ProShow will not explicitly tell you. If you want to have the math done for you, get my Tools for ProShow. All these calculations are built in and then some. If, however, you'd like to do the math yourself, the relationships are provided here. I hope this has proven useful and helpful to you. Thanks for watching.